So this will be the video on the differentiation, which is the this will be like introduction to differentiation, and I'll be explaining the concepts behind differentiation. So what led to the idea of differentiating things, how it comes with the fact that we have this particular drawing. So I'll be using this drawing to explain the meaning of differentiation. Okay. Now before I continue, I already talked about gradient and gradient or line and a curve in the other videos. So I'll be using this video now. This video is an explanation for the word for the fundamental idea of what of differentiation. That is what this video is about. So I'll be starting with this. Now, this is a graph. Let me say this: the y-axis I draw here is far that there is no space because of the size of the board. So I have to reduce the y-axis here. Okay. So let me start. So let's imagine this is a curve. Let's imagine this is a curve that goes like this. That comes like this. That is a curve. Now, next thing is the line here. The line that goes like this, PQ. We call it a secant. So line PQ is called a secant. That is the name of a line. Now let me define what that means. A secant is a line that passes through a curve at 2 points. So it enters a curve and comes out at the other point. That is what a secant is. That is one definition. The next definition we need important in this differentiation is what a tangent. What is a tangent? A tangent is a line that touches a curve at a particular point, just 1 point. So it touches a curve at a point. That is what a tangent is. While a secant can touch a curve at any number of points. So tangent is restricted to what? A single point, while a secant is what? Is restricted to a number of different points. For as long as it touches the curve more than 1 point, then that is called a what? That is called a secant. But a tangent is a line that touches a curve at just 1 point. Are you getting? So that is what a tangent is. Now in that case, consider definition. The line PQ is what? Is a secant because it touches the circle, the curve here, and you can see this curve continues and goes like this. Are you getting? So this is what? A secant. While a tangent touches the curve at a single point, which is what? Which is this. You can see. So the line that goes that touches the curve at this particular point, and that is line TPR. The line TPR is called a tangent. So the line TPR is called a tangent. That is what the line that touches the curve at a particular point. Now, next thing I want to explain is I've talked about gradient in my other videos. So the idea of differentiation is this: we want to know the gradient of the curve at this point x1. You can see I write x1 here. So I want the gradient of the point at this point x1. To find the gradient of the point at this point x1, I said to find the gradient of a curve, you take a point, that particular point you are being asked to, then you draw a line that touches the point at that point, which is what? Which is called a tangent. So you draw a tangent to touch that point on the curve. Then the next thing you now do is to find the gradient of the curve, you find the gradient of that line. So when you find the gradient of the line of the tangent, then you also looked for the gradient of the curve. Are you getting? So, but the problem there is I want to know my dy dx. So now if you look at the straight line I draw, this line TPR, it's extended like this, and the height is what? Is dy. Why this from here to here is what? Dx. Are you getting? So this is my dy and this is my what? This is my dx. Okay. So that is the triangle of the what? Of the line TPR, which is the tangent. Now, checking out the what? The secant. The secant also forms another triangle, and the triangle is this point and this point. You can see it comes like this and it goes like this. So when it meets, it forms a what? A tangent triangle, which is this triangle that goes like this. And this triangle also, you can also what? Take the what? The gradient, which is called the gradient of the secant. So for the second, the height here is what? Is change in y. Change in y from year to year. That is change in y. Why the the base, which is of the triangle, is what? Is change in x. You can see a triangle and x. That is the change in x. So this represents the base and this represents the height. Correct. So the next thing now, what actually brought the idea of differentiation is very simple in the sense that we want to know the dy dx of this. Are you getting? But there's a problem here. The problem is this: we can't find the dy dx of this line directly. So what Newton and Leibniz brought up was this. He said, okay, what if I take a line that cuts its curve at 2 points, which is between here and here? That forms a new line and that has a new gradient, which is what? Which is this, a secant. Are you getting? They now said this secant, when you start turning it like this. So let me draw it. So let's turn this line clockwise. Let's turn the line clockwise. So it goes in this direction. So imagine I turn this line and it goes like this, and it goes like this. What happens? You observe that this line, when you turn it, there will be a point where this line becomes exactly this line. You can try it. This line here, as it is here, if you keep turning it, it will reach somewhere here. This line PQ, this also it. Let me call it point Q. You can see after turning this line, I reach here. Then from here, I'll reach this point. So that idea is what is the basic principle in differentiation. Now, there is one observation whenever you start turning this line. This line, when you start turning it like this, there's an observation there. What is the observation? We observe that when you start turning this line, this x becomes smaller and approaches 0. So imagine I'm turning the line like this. The height here keeps going down like this. Like the base here keeps shrinking until it becomes what? 0. You can see. Imagine turning this line like this. Let me draw another line so you see what I'm saying. You can see this same line is this same line. The relating is I turned it to become this line. So when you turn this line and it reaches, when you turn this line continuously, data leads to what? This line TPR. But before that, you can see when I turn the line like this, before it had the base of this. Now, if you check the base of this particular line, you check the base at this same point, the line becomes what? Line becomes approaches 0, because this thing keeps shrinking like this as you turn it like this. As you start turning it like this becomes smaller and smaller until it meets exactly this line. So that fact is what is used in differentiation. So we say as the x approaches 0, the value of the gradient of this secant, which is change in y over change in x, as you start turning this line like this, turning it like this until it reaches, it becomes this line TPR. So in that process, that also what that means algebraically is that this line has a particular gradient, which is change in y over change in x. But when you start turning like this, it becomes this line, and that also becomes indirectly becomes this dy over this dx. because it's now the line TPR. So when you turn line PQ, turn it clockwise and it's reached here, it becomes line TPR, and that becomes the YDS. So algebraically, to write it down, we write it as this stuff becomes 0. That means as this place gets on shrinking and becomes this point turns this place decreases and goes down to what? 0, because as I turn the line, this place keeping on what? Shrinking to turn to this what? To turn to this particular line. So in that process, it becomes a new line and you have these approaches this. So this is what you see mostly in most calculus book, where you see this approaches this. But most people don't understand the reason why this goes to this. So this is the actual reason why it goes to that. So as you keep decreasing the what? The distance, this base distance, and you are turning this line clockwise, it becomes this line TPR. And that also means that the change in y over change in x of this line becomes, when you turn it to this line, becomes the dy dx. And what that also means is the gradient of the secant, which is change in y over change in x, approaches the tangent. You can see this tangent is what? Is TPR. It approaches the y dx. And that's exactly what brought about differentiation. So that process is used in getting the what? Derivative of a function. And also, I'm something about differentiation. Differentiation is a way of getting the gradient of a function analytically. So we have what is called analytically in mathematics, and we have what is called graphically. Graphically is when you use graph or certain stuff to get your answer. While analytically is when you solve something by hand without using any matter, like using your principles of mathematics. Those are called analytical calculation. So differentiation is based on the fact of getting the gradient of a function analytically. So understanding this concept is what brought out the word, we also call it the first principle. So as this approaches 0, this second gradient approaches the what? The tangent gradient.